Hello everyone. In this video, we would start discussing the IBSL 2020 Chemistry Paper 2. And in this video, we have covered the question 1. So let's start with the question. So in the first part of A, we need to state the full electronic configuration of chlorine atom. So chlorine has an atomic mass of 17. Okay. For 17, we will start using the Hunt's rule. So basically 1s2, 2s2, 2p6, 3s2, 3p5. Okay, because if you remember Hunt's rule, we start filling from this way: S, 3p, 3d, 4s, 4p, 4d. So firstly the 1s subshell will be filled, then the 2s, then 2p, then 3s, then 3p, and then 4s, and we exhaust our electrons when we reach 3p. So this is our final answer. Now, in the next question, we need to find out whether chlorine or chlorine minus ion has a larger radius. So chlorine is Cl. Okay, so chlorine has total 17 protons and 17 electrons, but Cl minus have 17 protons, but the number of electrons is 18. Okay, as the number of protons are same in both of these species, what happens is the outermost electron experiences the same amount of attractive force. Okay, so if I draw this chlorine atom here, so let's draw the outermost electrons. So here we have 8 outermost electrons. I mean 7 for chlorine. Yeah. So what happens is, as there are 17 protons here, all of the electrons will face the same attractive force here as compared to Cl minus. Okay, we will draw for Cl minus also. Okay, so both of them will have the same attractive force, but what happens is, as Cl minus has more electrons, so the electrons in the outermost orbit will face more repulsive force as compared to that of electrons of the outermost orbit of chlorine atom. As a result, what happens, due to this more repulsive force, the outermost radius would be larger for Cl minus atom. Okay, so here the answer is Cl minus, and the reason is more number of electrons would produce higher repulsive force at the outermost orbit. Okay, so this is the complete answer and explanation for question 2. Now, in the third part of A, we need to outline why chlorine atom has a smaller atomic radius than sulfur atom. This is fairly a very simple question. So what happens is, chlorine has 17 protons and 17 electrons, while sulfur has 16 protons and 16 electrons. So what happens is, you can see that chlorine has more protons as compared to sulfur. Okay, so if I draw sulfur and chlorine, let's say this is my sulfur, I'll draw the outermost electrons only, and let's say this is the chlorine. Okay, so sulfur will have 6 electrons in the outermost orbit, while chlorine will have 7 electrons here. See, in both the cases, the electrons are in the outermost orbit. Okay, what happens is, in chlorine, these electrons will have a much more attractive pull towards the nucleus as compared to sulfur, because chlorine has 17 protons while sulfur has 16 protons. Okay, so as a result, what happens, as the nucleus is pulling these electrons more with a much higher force as compared to that of sulfur, chlorine has a smaller atomic radius. So that is the reasoning for this question. So when we answer this question, we would write it in this way, that chlorine atom has a smaller radius because both chlorine and sulfur has uh, the same number of shells, but chlorine has higher number of protons. As a result, the attractive force on the outermost electrons of chlorine would be more, and hence it will have a smaller radius. So that's the answer to the third part. Now in this fourth part, we need to outline the reason for two peaks at M by Z at 35 and 37. The reason is fairly simple. Chlorine has two isotopes. One is chlorine 35 and another is chlorine 37. That's the reason we have two peaks at, one peak at 35 and one peak at 37. So as two isotopes, chlorine 35 and chlorine 37. This is why we get the two peaks. Now the fifth question asks us to explain the presence and relative abundance of the peak at MZ74. So we need to explain this peak. So this peak is formed when 2 chlorine 37 forms this chlorine molecule. Okay, so Cl37, Cl37. Okay, this molecule basically is this one. Okay, it has a total atomic mass of 74. Now, why is its abundance so low? Because the chlorine 37 is this peak. Okay, already the abundance of chlorine 37 is low. So our probability of 2 chlorine 37 coming together and forming the chlorine molecule will be very less. That's why its relative abundance is so low. Okay, so for the presence, this peak is formed by Cl37 molecule. The relative abundance is so low because the abundance of Cl37 is already very low, and chances of 2 Cl37 combining together is very low. So that's the full answer and reasoning to this question. Moving on to part B, we need to, here we have 2.67 grams of magnesium oxide that is added to 200 centimeter cube of 2 mole per decimeter cube HCl. Calculate the amount in mole magnesium 5 oxide, magnesium 4 oxide. So molar mass of Mn is basically 55 and molar mass of oxygen is 16. So the molar mass of MnO2 is 55 plus 2 times 16. So this comes out to be as, just a second, yeah, it comes out to be as 87 grams per mole. Okay, so number of moles is basically given weight by molar mass, that is 2.67 divided by 87. So this finally comes out to be as 0.0307 moles. Okay, and that's the final answer to this question. Now moving on to the next part, we need to find out the limiting reactant for this question. Now, I've already mentioned the reaction and the given information to us. We calculated the moles of MnO2 in the previous part. So yeah. So to calculate the limiting reactant, we need to find out, we need to know the moles of each of the components. So moles of MnO2, so this is for moles, would be 0.0307. Moles of HCl would be 2 mole per dm cube times 200 divided by 1000 dm cube. Okay, so finally this would be 0.4 moles. Okay, let me just recheck my calculations. So yeah, it would be 0.4. Now we would be using the magic ratio trick, that is n by stoichiometric coefficient of O2, that is moles per stoichiometric coefficient of MnO2, sorry. So here the moles of MnO2 is 0.0307 and the stoichiometric coefficient is 1. So this is for MnO2, and n by SC of HCl would be 0.4 by 4, that is 0.1. So as you see, n by SC of MnO2 is less than that of n by SC of HCl. Therefore, MnO2 is our limiting reagent. Okay, determine the excess amount in mole of the other reactant. Okay, so see, total there is 0.1 mole, 0.04 moles of HCl, and therefore there is 0.0307 moles of MnO4. So moles of HCl reacted would be, we need to apply the stoichiometry between MnO2 and HCl. Okay, so it would be, it is obviously in 1:4 ratio. So 1 by 4 times 0.0307. Okay, I believe there was a little error here. So it won't be 1 by 4, it would be 4 times. Okay, because it's HCl and MnO2. So 4 times, so 4 times 0.0307 would be 0.1228. Okay, so moles of HCl in excess would be total moles minus the amount that has been reacted. So our final answer comes out to be as 0.2772 moles. Okay, you can round it off to 2.77 also, not an issue. Okay, so in the next part, we need to calculate the volume of chlorine in dm cube produced if the reaction is conducted at standard temperature and pressure. Okay, so firstly, let's calculate the amount of moles of chlorine that would be produced. We've already calculated that MnO2 is our limiting reagent. So 1 mole of MnO2, and MnO2 and Cl2 is in 1:1 ratio. So moles of Cl2 would be equal to moles of MnO2, that is 0.0307. Volume of Cl2 would be, in your booklet it would be given that for 1 mole it is 22.4 liters. Okay, so we would just multiply it with this thing, and unit would be dm cube or liters, both are the same thing. So our final answer would be, yeah, so final answer is 0.688 dm cube. In the next part, we need to find out the oxidation state of manganese in MnO2 and MnCl2. Okay, this also again fairly simple. Let's assume that oxidation state of manganese in both of them are plus X. Okay, then MnO2 plus X plus 2 times oxidation state of oxygen with MnO2 is -2 would be equal to 0, because this is a neutral molecule. So X is equal to +4. So in the first compound, the oxidation state of manganese is +4. In the second one, let's assume it to be as X, and we have twice Cl. Cl has a -1 oxidation state. So X is equal to +2. So in the second one, the oxidation state of manganese in MnCl2 is +2. Okay. So deduce referring to oxidation state whether MnO2 is an oxidizing or a reducing agent. So see, MnO2, or the Mn in O2, the manganese in MnO2, it is getting reduced. It is going from +4 to +2. Something which gets reduced is known as the oxidizing agent. Okay, so MnO2 here is basically an oxidizing agent. So anything which itself gets reduced will oxidize the others. That's why it's known as the oxidizing agent.